we will be discussing about Physics Paper 1 MCQ paper 2016 October-November, variant is 11 and the subject code is 9702. In question number 1, what is the order of the Young modulus of a metal such as copper? So you must remember that the Young modulus of copper is 10 to the power 11 Pascal. Also, if we see it clearly, then Young modulus is equal to stress by strain, and stress is the force per unit area and strain is extension divided by original length. So this is our equation for Young modulus. And to extend a copper metal, we would require high amount of force. Since high amount of force is required, so Young modulus must be high. So it is the highest value, that is 10 to the power 11. In question number 2, the force F between 2 point charges Q1 and Q2, a distance r apart, is given by the equation. This is the equation where K is the constant. What is the SI base unit of K? To find the SI base unit of K, first of all we need to make K becomes a subject of formula. Then after rearranging this equation, we know that force is equal to mass into acceleration, and r is the distance and q is the charge, that is the point charges. So the SI unit of mass is kilogram, the SI unit of acceleration is meter per second square, the SI unit of r square, that is distance square, is meter square. Then charge, we know that current is equal to charge by time, so charge is equal to current into time. So current into time, and the SI unit of current is ampere, and for time it is second. So after rearranging this equation, we get our answer as B. Question number 3. An aeroplane can fly at a velocity x when moving through still air. When flying in wind, the aeroplane's velocity relative to the ground is y. So initially the aeroplane is moving at x, then due to the wind, the velocity becomes y respective to the ground. Which vector diagram shows the magnitude and the direction of the wind velocity w? So the option would be A, because initially the path of the aeroplane is x, then due to wind the aeroplane is displaced from its initial position, that is to y, and this is wind. And for option B, we can see that this is aeroplane x, and from its initial position, that is this position, it cannot be displaced by a large amount to y, so this is wrong. Then from in option C, we can see that instead of being displaced, or if it is just displaced from this initial position to this position, that is parallel to this line, that is y, then we cannot form a vector triangle, so this statement is also wrong. Then in option D, we can see that the initial path is x, and again by using this path of y, we cannot form a vector triangle. And here we can also see that the aeroplane is moving in this direction, but due to the wind, the direction of the aeroplane changes, so this statement is also wrong. So the option should be A. Question number 4. A voltmeter gives reading that are larger than the true value. So the voltmeter reading is larger and has a systematic error that varies with voltage. So the systematic error varies and the reading is larger. Which graph shows the calibration curve for the voltmeter? So among this graph, we can see that when the true value is 1, the voltmeter reading is larger. So this statement could be the answer. Then when the true value is 1, the voltmeter reading is larger. So this could be the answer. Then when the true value is 1, the voltmeter reading, we can see that it is less than 1. That is, the voltmeter reading is less. So it is not our answer. Then again, when the true value is 1, the voltmeter reading is less. So it is not our answer. So it could be either A or B. Then it is mentioned that the systematic error varies. And in option B, we can see that the systematic error remains the constant rate, or the systematic error is same. But here in option A, we can see that the systematic error varies. That means when the value is 1, the value is larger, but when the value is 2, the value is much larger than the first value. Then when the value is 3, the value is much larger than the second value. So here we can see that the systematic error varies, so the option should be A. Question number 5. A student uses a cathode ray oscilloscope to measure the period of a signal she sets the time base of the CRO to 5 millisecond per centimeter and observes a chest illustrated below. The chest has a length of 10 centimeter. What is the period of the signal? So period means the time taken for one complete wave. So we need to find the time taken for this one complete wave from this point to this point. So in this diagram we can see that there is 1, 2, 3, 3.5. So in 10 centimeter there is 3.5 waves. So that means 3.5 wave in 10 centimeter. So one wave takes about 2.85 centimeter. That means this one wave takes 2.85 centimeter. So what is the period of this one wave? We know that 1 centimeter is equal to this much time. So 2.85 centimeter is this much time. That is the period, and the period comes to be 1.4 into 10 to the power negative 2. So the answer should be D. Question number 6. A cyclist pedals along a raised horizontal track. At the end of the track, he travels horizontally into the air and onto a track that is vertically 2 meters lower. So at the end of the track, he travels horizontally. That means he has only horizontal component of velocity, and the vertical component of velocity here is 0. So the cyclist travels a horizontal distance of 6 meters in the air. So this 6 meters is covered in air. Air resistance is negligible. What is the horizontal velocity of the cyclist at the end of the higher track? So we need to find the horizontal component of velocity, that is HVH. So we must remember that the horizontal velocity remains constant since there is no air resistance. So there is no force in the horizontal direction, and since there is no force in the horizontal direction, so there is no acceleration in the horizontal direction, and so the horizontal component of velocity remains constant. So to calculate the horizontal component of velocity, we know the distance, that is horizontal distance, that is 6 meters, but we need to find the value of time. So what is the value of time? If you see the diagram clearly, then as the person lands to the ground at this point, it travels simultaneously 2 meters vertically and 6 meters horizontally. So when it lands, it covers a 2 meter vertical distance and a 6 meter horizontal distance. That means the time taken to travel this 2 meter is same as the time taken to travel 6 meter. So what is the time taken to travel this 2 meter? So we know the distance, that is 2 meter, and initially at this point we have given that it is moving horizontally. So the vertical component of velocity is 0. So the vertical component of velocity is 0, and we are considering the vertical component of velocity since the distance we take is vertical, that is 2 meter. So 2 meter vertical distance, vertical component of velocity is 0, and air resistance is negligible, so acceleration is 9.81. After substituting the value, we get the time when the person lands, and it covers a 2 meter distance as well as a 6 meter distance. Since it covers 6 meter distance also, so we know the distance and we know the value of time. So the velocity is distance by time. So distance divided by time that we have found, it comes to be 9.39, that is approximately 9.4 meter per second. Number 7. An astronaut on moon where there is no air resistance. So since there is no air resistance, so acceleration is same, throws a ball. So astronaut throws a ball. The ball's initial velocity has a vertical component of 8 meter per second, that is the vertical component, and the horizontal component of 4 meter per second. So this is the horizontal component. The acceleration of free fall on moon is 1.62 meter per second square. What will be the speed of the ball 9 seconds after it is being thrown? So since there is no air resistance, so there is no force acting on the ball in the horizontal direction. Since there is no force in the horizontal direction, so there is no acceleration in the horizontal direction, and since there is no acceleration in the horizontal direction, so the velocity remains constant. So the horizontal component of velocity is constant. And to find the speed, we know the horizontal component of velocity, but we need to find the vertical component of velocity. Because we know the horizontal, we need to find the vertical, and then we can find the resultant speed. So we just need to find the vertical component of velocity. So what is the vertical component of velocity? So we know the value of time, that is 9 seconds. We know the initial velocity, that is 8 meter per second, and acceleration, since it is moving upward, so the value of acceleration would be negative. So it is negative 1.62 meter per second square. And if it is moving downwards, then the value of acceleration is positive, because when it is moving downwards, its acceleration increases, but when it is moving upward, at certain point its velocity is 0. Since its velocity decreases, so the acceleration is negative, but when moving downward, the velocity increases, so the acceleration is positive. So as the object is moving upward, so its acceleration is negative, and we know the value of time, that is 9 seconds. So after substituting the value, we get a velocity that is negative 6.58 meter per second. The negative sign means that the object is moving downwards. So as we take the upward direction as positive 8 meter per second square, positive 8 meter per second. So for the upward movement, we take the velocity as positive. So for downward movement, we must take the velocity that is negative, that is already given. So what is the resultant velocity? Resultant velocity is the hypotenuse. So hypotenuse square is equal to adjacent square plus opposite square. So hypotenuse becomes root over 4 square plus the vertical component of velocity square. So we get 7.7 meter per second, that is B. Number 8. A car is traveling at a constant velocity. So the velocity is constant. At time t is equal to 0, the driver of the car sees an obstacle in the road and then brakes to halt. The graph shows the variation with time of the velocity of the car. How far does the car travel in 5 seconds after the driver sees the obstacle? So here we have just given the graph, and we need to find that how far the car travels, that means the distance. So we know that the area under the velocity time graph is the distance or the displacement. So we need to calculate the area under the graph, that is half into sum of two parallel sides into height. So sum of two parallel sides, that is 0.8 and 5, and the height is 20. So we get the distance, that is 5.8 meter. Sorry, this is not 5.8, this is actually 58. So 58 meter. So the answer should be C. Number 9. A car is stationary at traffic lights. When traffic lights change to green, the driver passes down sharply on the accelerator. The resultant horizontal force acting on the car varies with time. So we have given a graph for 4 seconds time. So which graph shows the variation with time for the speed of the car? Since we have given a 4 seconds time graph, so we know that force is equal to mass into acceleration. Also force is equal to change in momentum by change in time, and we have given the value of force and the time. So what is change in momentum? And we know that if we expand this further, then force is equal to change in momentum means that mass into change in velocity by change in time. And since it is a speed time graph, so we need to determine that what is the value of speed. So initially at this area, we can see that force is 0. So force is 0, that means here we can see that the velocity is also 0. Because as force is 0, so change in momentum is 0. Since change in momentum is 0, so the velocity is 0. So initially the velocity is 0 or the speed is 0. Then after we can see that the force must have some value, that is constant value. Since the value of force is constant, so change in momentum is constant. That means change in velocity is also a constant rate. So here we can see that the velocity increases at a constant rate. So the answer should be A. In question number 10, a beach wall falls vertically from a high hotel window. Air resistance is not negligible. Which graph shows the variation with time for the acceleration of the ball? So this is acceleration time graph. And since air resistance is not negligible or air resistance is present, so air resistance is present. So as air resistance is present, that means the acceleration value from 9.81, that is constant, it would decrease to a zero acceleration at terminal velocity. That means the acceleration from a higher value should decrease. So it is in option A, we can see that it starts from 0. So it does not start from 0, it actually starts from a higher value. So this statement is wrong. Then here we can see that the acceleration is constant. This would be the case when air resistance is negligible. But since air resistance is present, so the acceleration value must decrease from a higher value, that is decrease. Then here we can see that in option D, the acceleration increases. This would not be the case, because we know that acceleration decreases from a higher value, that is 9.81. So this statement is wrong. But in option C, we can see that the acceleration from a higher value, that is 9.81, it decreases due to the presence of air resistance, and as acceleration decreases, this occurs until the terminal velocity is reached, and at terminal velocity we know that the acceleration is 0. So until the terminal velocity is reached, that is acceleration is 0. So the option C would be the answer. Number 11. A car has a mass m. A person needs to push the car with force F in order to give the car an acceleration A. So initially this is the car. The person pushed the car with a force F to give an acceleration A. Then the person needs to push the car with a force 2F in order to give the car acceleration 3A. So now the person needs to push the car with a force 2F to give an acceleration, that is 3A. So which expression gives constant resistive force, that is R, opposing the motion of the car? So which equation gives the constant resistive force, that is R, acting on the car? So we know that the forward force minus backward force is equal to mass into acceleration. That is our first equation. And for the second equation, the forward force, that is 2F, minus backward force, that is the resistive force, is equal to mass into acceleration. So we get about two equations, and since we have given our answer in terms of M and A, so we need to eliminate the force, that is F. So we take F common in both the equation, and we equate the two values of F. Then equating this value and making the R becomes the subject of formula, since we need to find the constant resistive force R becomes the subject of formula, we get the value of R, that is MA. So the R would be MA, that is A. Number 12. A box is shown resting on the ground. Newton's third law implies that the forces are of equal magnitude are involved. So forces of equal magnitude are involved. That means these forces, that is P, Q, R, S, have equal magnitude. So force P and Q act on the block. So force P and Q are acting on the block, and force R and S are acting on the earth. So force R and S act on the earth, while force P and Q are acting on the block. For clarity, the forces shown are slightly separated. So these forces are slightly separated, and by separating the forces I have drawn this diagram. Which statement about the forces is correct? So it is clearly mentioned that the forces are of equal magnitude that I have given, but before discussing this, we need to know that what is gravitational force and what is contact force. So suppose this is the system, and in this system we can see that there is a gravitational force by earth on the object, and also there is a gravitational force by the object on the earth again, and the object is the block. So gravitational force on the object by the earth, and the gravitational force on the earth by the block. Again, there is a contact force, that is the contact force by the block on the earth, and there is a contact force by the earth on the block. So for this gravitational force or contact force, we have some things that is common. So for gravitational force and contact force, the forces are acting on different objects. So we can see that this force is acting on the earth, while this force is acting on the block, while this force is acting on the block, and while this force is acting on the earth, and this force is acting on the block. So as we can see that the objects are different, so the forces are that are exerted, that means we can see that the objects are different on which the forces are acting. So the objects are different and the forces are equal, and forces are of equal magnitude but act in opposite direction. So forces are of equal magnitude but act in opposite direction. So the forces are in opposite direction. Okay, so for all these forces, which statement about the forces is correct? So force P and Q are equal and opposite. So force P and Q are equal and opposite. Yes, this is true. And both forces are forces of contact. So we can say that P and Q are acting on the block, but as we know that contact force act on different objects, so this statement is wrong. Then for the second statement, we can say that Q and P are of equal magnitude and act in opposite direction, but both are gravitational force. So force Q and P, that is force Q and P are gravitational force. It is mentioned that it is their gravitational force, but as we know that gravitational force act on different objects. But here we can see that force P and Q act on the block, that means the same object. Since the forces are acting on the same object, so these are not the gravitational force. Then in the third statement, R is equal and opposite to S, and both are forces of contact. So for forces of contact, so this is R and this is S. So we can say that they are equal and opposite force, but these forces R and S are acting on the earth. That means these forces are acting on the same object. Since they are acting on the same object, so they are not the forces of contact. As we know that for contact force, the force must act on different object. So as the forces are acting on the same object, so this is not the force of contact. Then S is equal and opposite to Q, and both forces are gravitational force. So force S is equal and opposite to Q. Yes, these forces are equal and opposite, and both are gravitational force. So as the gravitational force, so they must act on different object. So S is acting on the earth and Q is acting on the block. So since these two forces are acting on different object, so this would be the answer, that is D. So as it is a gravitational force, that means the forces are of equal magnitude and direction, but the forces are of equal magnitude but act in opposite direction, and the forces must act on different object. So we can see that Q is acting on the block, so Q is acting on the block while S is acting on the earth. So this statement is correct because these two forces are acting on different object, so the option D would be the answer. Question number 13. Two spheres travel along the same line with velocities u1 and u2. They collide, and after collision their velocities are v1 and v2. So initial velocity of A is u1 and for B it is u2, and after collision the final velocity of A is v1 and the final velocity of B is v2. Then which collision is not elastic? So which collision is not elastic? But first of all, for elastic collision we know that total kinetic energy is conserved, and so we can use the equation that is kinetic energy is equal to half mv square to show that which equations are elastic and which are not. But this is time consuming because this is half mv square is quite time consuming. So we can use another formula, that is u1 plus v1 is equal to u2 plus v2. And so if you look at the options, then u1, that is 5 plus 3 comes to be 8 and 2 plus 6 is 8. So the collision is elastic. Then u1 plus v1, that is 3 plus 1 is 4 and negative 2 plus 6 is 4. So this is also elastic. Then 3 plus 0 is 3, negative 3 plus 6 is 3. So these three collisions are elastic. Then 2 plus negative 5, that is negative 3, and negative 5 plus negative 2, that is negative 7. So this collision is not elastic since u1 v1 is not equal to u2 v2. Therefore this is not an elastic collision. And if we discuss about that how we derive this formula, then initially A and B are moving, and since A is moving faster than B, thus A is able to catch up with B. So A is moving faster than B, so A is able to catch up with B. Then after the collision occurs, we know that the B has the highest speed or the highest velocity. Since if they collide, then obviously B would have the highest velocity after collision. So we write the equation in such a way that initial higher velocity minus lower velocity, that is higher velocity minus lower velocity, that is u1 minus u2. Then for the final we can see that v2 is greater, so greater minus smaller, that is v2 minus v1. So v2 minus v1, and if we write this in a simpler way, then u1 plus v1 is equal to u2 plus v2. So this is our derived equation. Number 14. A submarine has circular windows of diameter 0.30 meter. The windows can experience a maximum external pressure of 660 kilopascals. So we have given the value of pressure and the diameter before it crack. what is the minimum external force needed to crack the window? So we need to find the value of force. So we know the pressure, we know the diameter. So pressure is equal to force by area. We know the pressure, and by using the diameter we can find the area, and area is pi d square by 4. And so by using this equation we find the pressure, and the closest value that comes to be, that is 47,000, that is answer A. Number 15. Four beams of the same length each have three forces acting on them. Which beam has zero resultant force and zero resultant torque acting on it? So resultant force is 0, that means all the upward component is equal to downward component. So upward component is equal to downward component, so we can say that for the resultant force, there is 30 plus 50, it is 80, and the upward component is 80 and the downward component is 90, so it has not a zero resultant force. Then for this, the upward component is 70 plus 36, that is 106, and the downward component is also 106, that is upward is equal to downward, so resultant is 0. Then for question number C, 35 plus 28 is 63, and also there is downward 63, so upward is equal to downward, thus the resultant is 0. Then for question number D, that is 70 plus 42 is 112, that is 112, and also downward is 112, so upward, that is 112 minus 112, the resultant is 0. So except D, in all these three forces the resultant is 0. Then what is the resultant torque? Torque is the moment, and moment of force is the product of force and the perpendicular distance from the pivot. So, and for these moments we need to find the clockwise moment and the anti-clockwise moment. So according to our observation, the answer should be D, and its moment would be, since the resultant moment is 0, so clockwise moment is equal to anti-clockwise moment. So for this system and for all the systems, the center is this point, that means this is the pivot. So if we consider this as a pivot, then we can say that for 112 Newton force, the distance is 0, so perpendicular distance from the pivot is 0, so its moment is 0. And for 70 Newton force, it would exert a force upwards, that is in this direction, so this is anti-clockwise force. And what is the moment of this anti-clockwise force? 70 into 30, so it comes to be 2100. And for the clockwise moment, the clockwise moment would be 42 into 50, that is 2100. So we can see that the clockwise moment is equal to anti-clockwise moment, so the resultant moment is 0. Also, as both the distances are given in centimeter, so we do not need to actually convert them to meter. So this will be fine, and the answer should be D. Number 16. An air conditioning unit is supported by rigid beam PQ as shown. So this is the rigid beam PQ, which diagram shows the direction of the horizontal and the vertical component of forces acting on the ends of the beam. So we can see that since the air conditioning is supported, that means the system is at rest, and we need to find the horizontal and the vertical forces that acts on the beam. So this is our beam, and in this beam the force by the air conditioning would be acting downwards. Obviously the force by the air conditioning is acting downwards, so we can see that this force is acting upwards, so this is wrong. Then this is acting downwards, this is also acting downwards, this is acting upwards, so this is wrong. Then by the wall should exert a force in this direction, and among option B and C, we can see that for option C the force is in wrong direction, but for B it is in right direction, that is in this direction, so the answer should be B. Number 17. A hydroelectric power station uses gravitational potential energy. So it uses gravitational potential energy, that means the initial energy is the gravitational potential energy, that is initial I, of the water to generate electrical energy. So electrical energy is our final energy or the useful energy. So electrical energy is the useful energy and gravitational potential energy is the initial energy, that means the total energy. So in one particular power station, the mass of water falling per unit time is this. So mass per unit time, and the water falls through a height of, we have given the value of height, then the electrical power generated is this much power. And we already know that it uses gravitational potential energy to form electrical energy. That means this power is our useful power. So useful power formed. What is the efficiency of the power station? So to find the efficiency, useful energy output by total energy input. So what is the total energy? So we know the value of height. So what is the gravitational potential energy? Gravitational potential energy is mass into gravitational field strength into height. We know the mass per second, that means it is the mass. So we know the value of mass. We know the gravitational field strength or the acceleration due to gravitational field strength, that is 9.81, and the height is 120. So we get the gravitational potential energy. Then to find the useful energy output, we know the useful power. So energy is equal to power into time. So we know the value of power, and what is the value of time? If we remember, then we assume that the mass is for 1 second. So also the power is for 1 second. So since the mass is for 1 second, so for 1 second, what is the power? What is the energy? Energy is equal to power into time. So we know the value of power, and the time is 1 second. So we get the total energy output. So total energy output by total energy input, that is the gravitational potential energy, into 100%, we get the efficiency as 56.63, that is approximately 57%. What is the efficiency of the engine? So total energy input, that is total energy input, useful energy output, that is useful energy output by total energy input. So the answer should be C. Question number 19, it is just related to mechanics. A truck of mass 500 kg moves from rest, so initial speed is 0. At the top of the section of the track, that is 400 meter long and a height of 30 meters, so we have given the value of height. The frictional force acting on the truck is given, that is the value of frictional force throughout the journey. What is the final speed of the truck? So initially it has a kinetic energy, that is 0. So initially it has a gravitational potential energy, and the gravitational potential energy is converted to kinetic energy when work done by friction. Since it comes bottom of the slope, so at the bottom or at the ground level, the vertical height is 0. So gravitational potential energy is equal to final kinetic energy plus work done by friction. And for gravitational potential energy, we know the height, we know the mass, and the gravitational field strength is 9.81, is equal to half mv square plus work done by friction. So work done by friction is equal to force, and the distance moved in the direction of the force. So the distance moved in the direction of the force is this total distance, that is 400 meter. So we get the velocity as 13.73. 20. Which condition must apply for the work done by expanding a gas to be PV? So work done, we know, for work done we know the equation, that is work done is equal to force into distance. Also work done is equal to pressure into volume, and we know that pressure is equal to force by area, and we know that volume is equal to area into height. So initially we can see that the area cancels each other out, and it comes to be force into height or force into distance. These are both basically same. So we need to show that where P is the pressure and del V is the change in volume. So which condition must apply for the work? So which condition must apply? So we have given the equation, that is work done is equal to pressure into volume, and the volume is the change in volume. So the volume is changing but the pressure is constant. We cannot see a change in sign in front of the pressure, that means the pressure is constant. Since pressure is constant, so the condition should be pressure is constant, and the temperature is constant is for that equation, that is P1 V1 is equal to P2 V2, or PV is equal to constant. For this situation we use temperature as constant, but for now the pressure is constant. 21. A metal wire is stretched to the breaking point and the force extension graph is plotted. Which graph correctly labeled with the elastic region and the plastic region, and the area representing the work to stretch the wire until it breaks? So for a wire, if we think the points, then this is the limit of proportionality, and this point is the elastic limit. But the question asks us to find the elastic region. So which region is the elastic region? In which the region where the collision is elastic, it would be the elastic region, that is this region. So this region is also elastic. And what is the plastic region? This region is plastic region, that means after the elastic it comes plastic region. Then work done to stretch until it breaks. So work done would be the total force to needed to extend, that is the total area. So the answer should be D. Number 22. A copper wire hangs vertically from a fixed point. The load is attached to a lower end of the wire, producing an extension X. The wire obeys Hooke's law, which single change gives an extension 2x. So we know the equation, that is Young modulus is equal to force by area extension divided by original length, and for the extension we need to make the extension becomes the subject of formula. Then since we need the extension to be 2x, so for the extension to be 2x, we can say that extension is inversely proportional to cross sectional area. So if we increase the extension by 2, then we must decrease the area by 2. So half the cross sectional area of the wire. So this would be the answer. Question number 23. The table shows the wavelength of 5 electromagnetic waves. Which row correctly identifies the principal radiation for each of these wavelengths? So what are the wavelengths? So you must remember these values, that are for radio waves the wavelength is 10 to the power 4 to negative 1, for microwaves negative 1 to negative 3, negative 2 to negative 6, then 4 into 10 to the power negative 7 to 7 into 10 to the power negative 7, then 10 to the power negative 7 to negative 9, negative 9 to negative 12, and negative 10 to negative 16. Then the answer should be A, that for radio waves it is 10 to the power 4 to negative 1, that is in range of 10 to the power 2, so it would be radio waves. Then 10 to the power negative 2 is in this range, so this should be microwave. Then 10 to the power negative 6, so we can see that 10 to the power negative 6 is between negative 2 to negative 6, so it would be infrared radiation. Then negative 10, 10 to the power negative 10 is between negative 9 and negative 12, so it would be X-ray. Then 10 to the power negative 14, so we can see that 10 to the power negative 14 is in between 10 to the power negative 10 and 10 to the power negative 16, so 10 to the power negative 14 should be gamma ray. So the answer should be A. 24. The first two stationary waves occur when the air column lengths are this and this. So first two stationary waves occur, that means two stationary waves. Then what are the wavelength of the sound wave? So we need to find the wavelength. So as we can see that this is an open end, so there should be an antinode, and this is a closed end, so there should be a node. So this would be for the first, and for the second it would be this wave, and for the third this would like this wave. And if both the ends are open, then this would be the first wave, then this would be the second. And we can see that for the both the ends are open, we can see that this wavelength, if we complete this wavelength, then this should be at the end, that means this is half the wavelength, so it would be lambda by 2. Then for this wavelength we can see that this completes a total wavelength, so this would be 2 lambda by 2, that is lambda. Then it would increase in such a way, that is lambda by 2, 2 lambda by 2, 3 lambda by 2, 4 lambda by 2, 5 lambda by 2, 6 lambda by 2, etc. And for the one end is open and the one end is closed, it would be lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4, then 9 lambda by 4, 11 lambda by 4. This would increase in such a way. So you should remember the order of increase and how the waves are formed. Then since it is a open end and a closed end, and for the first and the second waves, that is this and this, so we have given the value, that is 0.14 and 0.42. so for the first, that is 0.14, so if we equate this, then it comes to be lambda is equal to 0.56, that is D. Also if we use the second, that is 3 lambda by 4 is equal to 0.42, we would get the same value of lambda, that is 0.56 meter. So the answer should be D. In question number 25, the graph shows the variation with time of the displacement x of a gas molecule as a continuous sound wave passes through a gas. the velocity of sound in the gas is given. All the graphs below have same zero time as the graph above. What is the displacement time graph for the molecule that is a distance this meter further from the source of sound? So by using this information, first of all, we can see that our graphs are time and displacement graph. So we need to find the period of the wave. So we can see that initially it has a period of 500, and so our resulting graph should also have a period of 500, but we can see that all have a period of 500, so we cannot eliminate anyone. Then we need to find the wavelength. So what is the wavelength? So v is equal to f lambda. We know the value of v, we know the value of frequency. So by using time, we need to find the frequency, that is frequency is equal to 1 by time period. So we get the frequency. And what is the lambda? Lambda is equal to v by f, so we get the lambda. And we can see that the lambda is same as the distance. So since the lambda is same as distance, so what would be the phase difference? Phase difference is equal to approximate change in d, that is this value, by lambda, that is this value, into 360 degree. So after calculating, or we know that this cancels with this cancels, so the answer should be 1, and this is multiplied with 360, so this should be 360 degree. So our resulting wave is 360 degree out of phase or 0 degree out of phase. That means our resulting wave or our final wave should be in phase with the wave that is given. So since the wave is in phase, so the displacement value would be same. That means initially the particle is moving upward, so initially it move upward from a point 0, so it is moving upward with the highest point, so this is wrong. Here it is moving downward and we need to upward movement, so this is wrong. Then here it is starting from downward, so this is wrong. But here we can see that it starts from 0 and it is moving upward, so this is same as that is our given graph. So it is moving upward then downward and it starts from 0, so it starts from 0, then it move up and down. So this would be our resultant wave molecule displacement time graph. So the answer should be D. Number 26. The warning signal on an ambulance has a frequency of 600 Hz. The speed of the sound is given. The ambulance is traveling at a constant velocity given towards the observer. So initial position of the ambulance, observer, final position of the ambulance. Which overall change in the observed frequency takes place between the time at which the ambulance is a long distance behind the observer, that is it is moving towards the observer, then and when it is a long distance in front of the observer, that is it is moving away from the observer. And we need to find the change, that is change in observed frequency. So what is the change in observed frequency? First of all, since the ambulance is moving towards the observer, so as it moves towards, so towards means minus, so it would be v minus vs. Then as it moves away, so it would be plus, so v plus vs. Then after substituting the value, we know the value of frequency, that is 600. So 600 into speed of sound, that is v, that is 330 divided by v minus vs, so v minus vs and v plus vs. After calculating, we get our two frequencies when it is moving towards and when it is moving away. Now to find the change in frequency, we need to subtract the highest value. We need to subtract highest value from the lowest value, that is highest value minus lowest value. So highest value minus lowest value, we get the change in frequency, that is 91.35 Hz, that is 91 Hz. So the answer should be C. 27. The diagram X and Y show the passage of water waves around an obstacle through a gap. The thick lines are the barriers, that is these thick lines are the barrier then to the wave, and each thin line represents wavefront. So these are the wavefronts. Which statement is correct? So which statement is correct? First of all, if you see both this diagram, then we can see that it is usually diffraction or diffraction occurs. So diffraction occurs, it is not interference, since there is no resulting wave formed from the given waves, or as there is only one wave, so no resultant wave is formed, so there is no interference. So it would obviously a diffraction, since the waves are diffracted from the initial path, so they are diffracted, and both x and y represent diffraction, so the answer would be A. Number 28. The diagram shows a long rope fixed at one end. The other end is moved up and down, setting up a stationary wave. So this side is moving up and down, and this is fixed end. What is the phase difference between the oscillation of x and y? So since x and y are within two nodes, that is this node and this node, so the phase difference should be 0 degree. And if suppose that one of the point is at this point and other is at this point, then we can see that these 2 points are not within the same node, so the phase difference would be 180 degree. But for now, since they are within the same node, that is this node and this node, or within two nodes, so the phase difference should be 0 degree. 29. A diffraction grating. So this is a diffraction grating question. That means d sin theta is equal to n lambda is used to measure the wavelength of monochromatic light. The spacing of the slits in the grating is given. So we have given the spacing of the slit, that means the value of d. Then the angle between the first order diffraction maxima is this value. So this is our 0 order, and this is the first order, and this is the first order, and we have given the total angle. And for our sin theta, we get the value of theta, that is from the 0 order to the first order. So from the 0 to the first order, it would be 60 by 2. So sin theta by n. So what is the value of n? So we take the angle for the first order, that is from 0 to the first order. So we can see that from 0 the order is 1, so the value of n is 1. We take the angle that is for 1, so the order should be 1, so 1. So after calculating, we get the wavelength as 5.75 into 10 to the power negative 7, that is 575 nanometer. So answer should be C. Question number 30, it is from electric field, so this is not the syllabus. Then 31 is also from electric field, and 32 is also from electric field. Then question number 33, so we need to find the value of current and resistance. So we have given the power and the voltage. So current is equal to, we know that power is equal to VI, so I would be power by voltage, sorry, this would be voltage. So power by voltage is 12.91, that is 12.9 and 12.9. Then what is the resistance? So to find the resistance, since we know the value of current, so we know the value of power, voltage and current, so we can use any of this equation, that is power is equal to V square by R, power is equal to I square R, and R is equal to V by I. So we use the equation, that is the first equation. So power is equal to V square by R, so we get from this equation, that is R is equal to V square by power, that is 3.10 into 10 to the power 3, since it is kilo. So we get the resistance as 18.58, that is 18.6. So the answer should be C. Number 34. A thick copper wire is connected to a thin copper wire in series with a cell as shown. So this is thick copper wire and this is thin copper wire, and they are connected in series. What is significantly less in thick wire than thin wire? So we know the equation, that is I is equal to N AVQ, and since there is a variation in cross-sectional area, so first of all we need to make A becomes a subjective formula. So A would be I by N VQ. A would be I by NVQ. So I by NVQ. So this is our resulting formula, and for this formula we know that since the system is connected in series, so in series we know that current is same. So current is basically same. Then Q, we know that Q is the elementary charge, that is 1.6 into 10 to the power minus 19 coulomb. So Q is also same. Then we get the relationship as A is equal to N by NV, that is 1 by NV. So A is equal to 1 by NV, and where N is the number of free electrons per unit volume and V is the mean drift velocity. So what is N? N is the number of free electrons per unit volume. So if we compare, then for thicker wire the volume is more. So volume is more, also number of free electrons should be more in the more volume. So volume is more and the number of free electrons are more. So N is same. And for thin wire we can see that the volume is less, since it is a thin wire, so the volume is less and the number of free electrons is also less. so volume is less, number of free electrons is less, so the ratio is same. That is, for this ratio and this ratio is same. That is, since the in value is more for the thick wire, so in value is more and the volume is more, so these two cancel each other out and in basically remains constant. Again, for the thin wire, we can see that in is less, that is the volume is less. Since for the thin wire the volume is less and the in value is also less, so basically the small n value, that is the number of electrons per unit volume, remains constant. So also in value is constant. Thus for the thick wire, if we increase the area, that means for the thick wire, if we increase the area, then the mean drift velocity is less. So the drift velocity of the electron is less, that is less. And for the other options, the charge passing a point per unit time is basically current, that is current is equal to charge by time. Then number of free electrons passing a point per unit time, this also refers to a current. Then number density of free electrons. Since we can see that for the thick wire the number of electrons is more and the volume is more, so the number density remains the same. Also for the thin wire the volume is less and the number density is less, so that means the number of free electrons is less, so the number density remains constant. So number density is basically constant, so this would not be the answer. So the answer should be B, that is the mean drift velocity decreases with increase in cross sectional area. That means with increase in cross sectional area, mean drift velocity decreases. Number 35. What is a typical value for the order of magnitude of resistivity of the copper wire? So we know that resistance is equal to resistivity into length by cross sectional area. So resistivity would be resistance into cross sectional area by length, and since copper is a good conductor, so its resistance is obviously less. Since its resistance is less, so its resistivity must be less. So we remove the highest value, and for these two least value we can see that you have to remember that the resistivity value basically comes within 10 to the power negative 8, then 10 to the power negative 13. So the answer should be B. Or from Google, it comes to be 10 to the power negative 8, that it is given 10 to the power negative 8 and no higher value is given. So you should remember this. So by using this formula, we just eliminate two larger values, but you should remember this value to get the correct answer, and this is not the answer. 36. In the circuit shown, the reading on the ammeter is 0. So the reading on the ammeter is 0, that is 0. 4 resistors have different resistances R1, R2, R3, R4. Which equation is correct? So you should remember that since the ammeter reading is 0, that means the voltage in this resistor is same as the voltage in this resistor, that is V. And since these two voltages are same, so the ammeter reading is 0. And you must also remember that in parallel circuit the voltage is same, that means the voltage in this circuit is same as the voltage in this circuit. So we know that the total voltage is same and this voltage is also same, so that is this voltage and this voltage are same and the total voltages are also same. That means this value and this value of voltage is also same, that is these two values are same. And since these two values are same, that means the voltage of R1 by voltage of R3 is same as the ratio of voltage of R2 by voltage of R4. And since we know that voltage is directly proportional to resistance, so the voltage ratio is the same as the resistance ratio. So the resistance of R1 by R3 is same as the resistance of R2 by R4. And if we just rearrange this equation, then R1 into R4 is equal to R2 into R3, that is R2 into R3. So the answer should be D. Again, if I just explain it quickly, then voltage is directly proportional to resistance, so the ratio of voltage is same as the ratio of resistance. So as the ammeter reading is 0, so the voltage in this resistor is same as the voltage in this resistor, and since they are arranged in parallel, so the total voltage in the parallel circuit is same. Since the total voltage is same, and these voltages are also same, that means these voltages are also same. And so what is the ratio? The ratio would be the voltage in this resistor by voltage in this resistor, and since we know the ratio of voltage and the resistance is same, since voltage is directly proportional to resistance, so the resistance in R1 by resistance in R3 is equal to resistance in R2 by resistance in R4, and if we rearrange we get the answer D. 7. So this is the diagram we have given. Which equation is correct? So we can see that I1 is going inside the circuit and I2 and I3 are the branched. So I1 is equal to I2 plus I3. So the answer should be A. Number 38. What is a proton? So a proton is a hadron, and so this is basically the information, and we can see that hadron, so we can see that for the hadron, proton is an example, so proton is a hadron, and you should also remember this informations and this information. 39. What is the correct description of gamma ray and beta minus particle? So gamma ray, it is basically a radiation, so electromagnetic radiation, and beta minus particle, it is a high speed electron. Since beta minus particle is also considered as an electron, so it is a high speed electron, so the answer should be C. 40. Nucleus P and S are compared. Which statement is correct? So P, after emission of beta minus particle, so after emission beta minus particle, we can see that neutron changes to a proton, so the proton number increases by 1. Then for Q, as alpha particle is emitted and alpha particle contains 2 protons, so since alpha particle is emitted, so proton number decreases by 2. Then R, since beta minus particle is emitted, as beta minus particle is emitted, we can see that neutron changes to a proton, thus proton number increases by 1 and it forms S. So which statement is correct? We can see that initially P's proton number increases by 1, then decreases by 2, then again increases by 1. That is, this decrease by 2 and increase by 1 cancels each other out. That means P has the same number of protons as S. So since they have the same number of protons, so they are the isotopes of the same element. Since isotopes have the same number of protons and electrons but different number of neutrons.